Every time you click Login, Search, or Buy, you are initiating a conversation. It is not a conversation between humans, but between a web server and a database. This hidden dialogue is the backbone of the modern internet. In this world, data is stored in massive digital filing cabinets, and the key to these cabinets is a language called SQL, or Structured Query Language. But what happens when that language is turned against itself? Welcome to the anatomy of a SQL injection. For decades, this vulnerability has topped the charts of the most dangerous software weaknesses. It is simple, elegant, and devastatingly effective. To understand it, we first have to understand how a normal query works. Imagine a librarian. You give them a title, and they go find the book. This is the intended relationship. But what if the title you gave them was not a title at all, but a command to burn the library down?
Normally, a server takes your input, like a username, and places it inside a template. It says, find the user where the name matches this specific string. The database processes this as a search parameter. But a SQL injection occurs when an attacker uses special characters, specifically the single quote, to break out of that string. By doing this, they trick the database into thinking the user's input is actually part of the computer's code. The most famous example is the string quote or 1 equals 1 dash dash. To a human, it looks like gibberish. To a database, it is a mathematical truth that is always valid. The 1 equals 1 portion makes the entire logic check true, regardless of what the password is. The two dashes at the end are even more clever. They tell the database to ignore every line of code that comes after them, effectively deleting the password requirement entirely. In an instant, the locked gate is not just bypassed, it ceases to exist. As security evolved, so did the injections. Hackers developed blind SQL injection. In this scenario, the attacker cannot see the data directly. Instead, they ask the database a series of yes or no questions. Is the first letter of the administrator's password an A? If the page loads normally, the answer is yes. If it gives an error, the answer is no. By automating this process, a hacker can extract entire databases, character by character, through the digital equivalent of a game of 20 questions. The history of this attack is long. It was first documented in 1998, yet decades later, it remains one of the most common ways that major corporations are breached. From retail giants to government agencies, no one is immune if their code is not written with security in mind. The impact is staggering. Millions of credit card numbers, personal identities, and private messages leaked to the dark web. But there is a solution. It is called parameterization, or prepared statements. Instead of building a query like a sentence where anyone can add their own words, the code creates a rigid template. The user's input is treated as literal data, never as code. Even if a user enters a malicious string, the database simply sees it as a very strange and incorrect username. It is the difference between a librarian following instructions written on a scrap of paper and a librarian who only accepts a specific form with no room for extra notes. Beyond code, we use web application firewalls and input sanitization as layers of defense. The battle against SQL injection is a fundamental part of cybersecurity. It reminds us that in the digital age, the way we speak to machines matters just as much as what we say. I am CyberClarity. Protect your data. Sanitize your inputs. Knowledge is the ultimate firewall.